We're now going to look at a topic from number theory called congruence. But before watching this video, I would encourage you to look at the in-class activities in the file Introduction to Congruence. Now, these will not be problems that will be on the quiz, but they will help you better understand what's going on in the video, so I would encourage you to look at those. All right, so as I mentioned, we are going to look at the concept of congruence of integers. We're going to use a days of the week model to help us understand what congruent integers are modulo some number n. We are going to then use that to find a formal definition of congruence, and then we'll look at an example. All right, so as a model, we're going to use days of the week. So we're going to let n be a natural number, and we're going to let a and b be integers. And when we say a is congruent to b mod n, what that's going to mean to us is that a and b represent the same day of the week when you have n days in a week. So we are used to having 7 days in a week, but this is an expanded understanding of how calendars work. We can choose any number of days to be in the week. So to look at an example, we might ask, is 7 congruent to 25 mod 9? So since we're doing mod 9, that means we are using 9 days in a week. And if we want to know if 7 and 25 are on the same day of the week, we might want to look at how many days there are between them. There are 18 days between them, and since there are 9 days in a week, that means there are exactly 2 weeks between 25 and 7. And since there are exactly 2 weeks between them, they have to be the same day of the week, which means yes, 7 is congruent to 25 mod 9. If we look at whether or not 12 is congruent to 19 mod 4, here we have 7 days between 12 and 19. And under an ordinary calendar, yeah, that would be exactly 1 week away. They would be the same day of the week. But remember, mod 4 says there are 4 days in a week. And that means 7 days is somewhere between 1 and 2 weeks, which means that 12 and 19 are not the same day of the week, and so they are not congruent mod 4. So if we want to look at a formal definition of congruence, we let n be a natural number, and we let a and b be anti-integers. We say that a is congruent to b mod n if one of the following occurs. So one way of understanding that is a is equal to b plus nk for some integer k. And that looks a little strange, but to connect that a little bit back to the days of the week, what's happening here is, remember, n is the number of days in a week, it's mod n. K is then going to be the number of weeks between a and b. If you have n days in a week and k weeks, the number of days you get from that is n times k. So a equal b plus nk means that they are exactly the same day of the week. Now, if we take that equation and subtract b from both sides, we can say that n divides evenly into a minus b is another way of understanding congruence. So again, we take that equation, subtract b from both sides of the equation, and you can see that that is exactly what it means for n to divide evenly into a minus b. And you can also mess around with that equation to show that n divides evenly into b minus a is a similar understanding of what congruence means. So 3 different ways of understanding the exact same definition. All right, so now what I want to do is skip ahead a little bit to some of the problems we're going to look at in the next set of in-class activities. First of all, to practice some of our congruence, but also to get ready for those activities. So what I would like to do is find the smallest positive integer x, such that x is congruent to 937 mod 5. All right, so let's see if we can do this. What kind of strategies we might use? Well, first of all, we know that x is congruent to 937 mod 5. By the definition, that means x is equal to 937 plus 5 times k for some integer k, right? We start with 937. We add k weeks to that to get to x. Now, we want small values of x, small positive values of x, which suggests that maybe we want to look at some negative values for k. The negative values for k will tend to make that number smaller, and that will get us closer to 0, which is what we're looking for. So just to get us warmed up, let's try k equals negative 100. If we do that, we get 937 plus 5 times negative 100. 937 minus 500 gives us 437. Well, that's a lot better than 937, but to be honest, it's not close. We can do a lot better than that. But if we look carefully, it looks like each time we decrease k by 1, in other words, take k and make it negative by 1 more unit, that decreases the value of x by 5. And if you think about what kind of arithmetic operation we're talking about, that sounds a lot like division. So maybe we can use division to help us find a good value for k. So if we take 937 divided by 5, we get 187.4. That's obviously not an integer, but if we just ignore that 0.4, right, and make it a negative number, right, because we need it to be negative, it makes sense to try k equal negative 187. Let's see what happens there. So we get 937 plus 5 times negative 187, and we get 2. And if you're wondering whether, well, maybe we can do better than 2, get a smaller positive number, why can't we get 1, for instance? Well, if we make that k any smaller, any more negative, then we're going to be subtracting at least 5 away from that 2, which is going to put us in negative territory, which we don't want. So actually, it turns out 2 is the smallest one we can get. And if you're paying attention to this whole division thing that we've been doing, 2 is actually the remainder that we get when we divide 937 by 5. So it appears that there is some connection between congruence, division, and remainders, which we will explore in the next set of activities. All right, so now go ahead and work on the PDF file called More Congruence that is included with this video.